Hello everyone, so in this video we're going to see JEE Advanced 2025 paper 1 solutions. So there are certain questions which are ambiguous. We'll also discuss those questions. So without any further delay, let's begin the session. Right, so this is the question 1 of JEE Mains 2025 paper 1. So let us first read the question. So the center of the disk of radius small r and mass m is attached to the spring of spring constant k, and inside a ring of radius capital R which is greater than small r as shown in the figure. So there is a disk which is undergoing simple harmonic motion on the inner periphery of the ring. Right, the other end of the spring is attached on the periphery of the ring. So the spring is connected somewhere here on the ring. Both the ring and the disk are in the same vertical plane, and the disk can only roll along the inside periphery of the ring without slipping. The spring can only be stretched or compressed along the periphery following the Hooke's law. So we can apply kx as the force, right, by the spring. In equilibrium, the distance is at the disk is at the bottom of the ring, assuming small displacement of the disk, the time period. So basically we have to find the angular frequency of the oscillation. Now this question is a similar question is there in HCV. So I would rate this question as easy because it is there already there in HCV, so only a spring is being attached. So let us try to solve this by using force approach. So here if we displace, let us say the angular displacement of the disk with the vertical is theta, right, and let me take this arc length as x. So what we can say, if I draw a tangent at this particular point, then the tangent will make an angle of theta with the horizontal, right? By geometry we can prove that. So if I draw a tangent, now this angle will be theta. Now what we're going to do, will show all the forces acting on the disk. So there will be a normal reaction, there will be a weight in the downward direction, and apart from this there will be a spring force, and spring force will be compressive. Spring force is undergoing elongation, so there will be a force which is bringing it back to the equilibrium position. So we can say there will be a spring force kx in this direction, right? So now let us resolve this force along the tangent and normal to the tangent. So let me show all the forces. So let's say this is the tangent and this is normal reaction. We have weight component normal to the incline mg cos theta, and there is a weight component along the incline, so mg sin theta, and there will be a spring force kx. And let us say due to these forces there is an acceleration a at this very instant. So we can say by applying Newton's second law we can write kx plus mg sin theta minus, and there has to be a frictional force up the incline, right? So let me also show frictional force, because only then it will be able to roll, right, in an anti-clockwise direction, because there is no other force which is providing torque about the axis passing through the center of mass. So minus f, and this should be equals to mass times acceleration, and we can write the torque equation, that will be f times r, torque is equals to I alpha, and moment of inertia will be mr square by 2. And since it is rolling, acceleration can be written as a by r, angular acceleration can be written as a by r, so we can eliminate r. Now from these two equations, if we add them, we can eliminate friction. So we will get kx plus mg, and since theta is very small, because for small oscillation we have to calculate the angular frequency, we can write sin theta as theta, and theta from this diagram is nothing but, so theta can be written as and this radius of the circular arc in which the center of mass is moving is r minus small r, right? So the radius of that will be r minus small r. So theta can be written as x divided by r minus small r. So we can write mg x upon r minus small r, and then this should be equals to 3 by 2 ma. Now let us divide throughout by mass. So we'll get m here. Now let us take this 3 by 2 on the other side. So we will get 2 by 3 times k by m plus g upon r minus small r times x is equals to a. Since we have displaced the disk in the right direction, so acceleration is in the left direction, so we can put a negative sign here. Now this is a simple harmonic motion, right, where acceleration is proportional to the displacement from the mean position, and I'm treating this arc x, this x distance, just like a horizontal linear simple harmonic motion, because theta is very small. Now from this we can say this is the angular frequency, right? So this factor is square of the angular frequency. So this is omega square. So omega comes out to be root of 2 by 3 k by m plus g upon r minus small r. So if we look at the options, option A is the right answer. Now this is the second question of JEE Advanced 2025 paper 1. So let us see the question. So here in a scattering experiment, a particle of mass 2m collides with another particle of mass m which is initially at rest. Assuming the collision to be perfectly elastic, the maximum angular deviation theta of heavy particle as shown in the figure in radians is. So we have to find answer in radian or the angle of scattering. So here the most easiest approach would be in the center of mass frame, but it can be solved analytically. So I'm going to use center of mass concept. So what we have given, so we have given mass 2m. Let us say its initial velocity is u, and there is a particle of mass m which is at rest, right? So if I consider center of mass frame, then velocity of center of mass will be 2m times u plus m times 0 divided by sum of the masses, which will be 3m. So this comes out to be 2u by 3. Now what you can do, let us find the velocity of both the masses in center of mass frame. So this is the center of mass which is moving in the right direction with 2u by 3. So velocity of 2m with respect to center of mass will be in the right direction, that will be u by 3, and the velocity of small m will be in the left direction, and that will be 2u by 3. And you should always remember, in center of mass frame the momentum will be 0, right, for the system. So if you multiply, so 2m times u by 3 plus m times minus 2u by 3, so it will be 0, right? So momentum will be 0 in center of mass frame. So what we can say, before collision, this is the momentum of 2m, and we can say the momentum of m will be negative of this value, right? Let me call this as p1, right, before collision, right? So now let us consider the case after collision. Even in this case, since we have elastic collision, the momentum magnitude won't change, because there is kinetic energy will remain same, right? So kinetic energy will not change. So after collision, let us say the momentum of 2m is pointing in this direction. I'm assuming just random direction, right? Let us say this is p2, and the momentum of m will be in the opposite direction to keep it 0. That will be minus p2. So that is for, let me just name it, that is for small m, and this is for 2m, right? So if I want to find the velocity, or say the momentum in ground frame, so let us see what we can do. So velocity of 2m will be velocity of 2m with respect to center of mass plus velocity of center of mass, right? Since there is no external force acting on the system, velocity of center of mass won't change. And so if I show the velocity of center of mass, this will be velocity of center of mass, which is nothing but 2u by 3 and this is, let us say, the new momentum of 2m in this direction. So if we take the resultant of these two, we will get the momentum of 2m, right? So that is the momentum after collision. And this will be the angle of scattering, right? Or this is the you can say deflection of 2m, right? So that is the angle of scattering. Now we want to maximize this angle. So what we can do, we can assume that this P2, it can be in any direction, right? Depending upon the line of impact. Okay. So if I consider P2 such that this P vector P2m is tangent to this circle, right? If that is the case, then this theta will be maximum, right? So that is for maximum theta. So now basically we have a right angle triangle. So let me redraw this. So this will be 2u by 3, that is the velocity of center of mass. Then we have the new velocity and its magnitude will be nothing but same, right? So it will be u by 3 only, right? And this is 90 degree and this angle is theta. Now from this right angle triangle, we can say sine theta will be perpendicular upon hypotenuse. So that will be u by 3 divided by 2u by 3. So which comes out to be 1 by 2, right? So theta will be 30 degrees or pi by 6. So what you can remember, when the colliding particle or the striker is greater than the target, right? Mass of the striker is greater than the target. Like in this case, we have 2m is the striker. So this is the striker and this is the target particle, right, on which it is hitting. So if mass of striker is greater than mass of the target, then the maximum scattering will be given as sine inverse mass of target divided by mass of striker. But if mass of striker is less than mass of target, in that case theta max will be 180 degrees. So small particle will retrace its path. So this you should remember. So in this case, mass of striker is greater than mass of the target. So the answer will be pi by 6. So option D should be the right answer. Now this is the third question of JEE Advanced 2025 paper 1. So let us first read the question. A conducting square loop initially lies in the xy xz plane with its lower edge hinged along the x-axis. So they're talking about this edge which is hinged along the x-axis. Only in the region y greater than or equals to 0, there is a time-dependent magnetic field pointing along the z direction, where magnetic field is given as B naught cos omega t k cap, where B naught is a constant. The magnetic field is 0 everywhere else. At time t equals to 0, the loop starts rotating with a constant angular speed omega about the x-axis in the clockwise direction as viewed from the x-axis as shown in the figure, ignoring self-inductance of the loop and the gravity. Which of the following plots correctly represents the induced EMF in the loop as a function of time? Right. So again, it's a typical question where we have to find the instantaneous flux. Then we're going to differentiate that by applying like Faraday's law, and we'll be able to get the induced EMF. So let us see first, let me look at this problem from the positive x-axis. So if I look at it from the positive x-axis, I will see YZ plane. And let us say this will be the square loop. Let me name it, right? So let us say this is A, this is O, this is B, and this is C, right? So we can say this point will be BC and this will be AO. Now this angle is omega t. So if I show the area vector, so let us take a normal to this area. So this will be the area vector, right? So we can clearly see that this angle is omega t. So the area vector makes an angle of 90 minus omega t with the magnetic field. So magnetic field is pointing in the Z direction. So this is B, right? So if I want to find the instantaneous flux, so that will be B A cos of the angle between B vector and the A vector, which is 90 minus omega t. So it comes out to be, and B is nothing but B naught cos omega t. And area, do we have given the length? Okay, let us take it as A only. And this will be sine omega t. So we are getting the instantaneous flux as B naught by 2 times A sine 2 omega t. So we got this. Now what we can do, we can differentiate this. So induced EMF will be minus d phi by dt. So which comes out to be minus B naught A by 2 times 2 omega times cos 2 omega t, right? So can you see this induced EMF is, let me write it as minus E naught cos 2 omega t. It's negative cosine function, right, with the angular frequency of 2 omega. Or you can say the time period will be 2 pi by 2 omega, so that will be pi by omega. So for half of the time period, we can say it will rotate by an angle of pi by an angle of 180 degrees. And after that, there won't be any magnetic field, so there won't be any flux, so there won't be any induced EMF, right? So let us see. So it's a cosine function. So if you look at the option, we can say option B is incorrect, because we know that when it completes one rotation, there will be an instant when the induced EMF will be 0. So B can't be is wrong. C is also wrong, right? Now we have to check for A and D, right? And if you look at D, it is basically negative sine function, right? So D is also incorrect. So the correct answer should be option A. So this is the question 4 of JEE Advanced 2025 paper 1. A very basic question. Let us see. Figure shows, one shows the configuration of main scale and vernier scale before measurement. So before measurement, if you can see the 0 of the vernier scale is coinciding with the 0 of the main scale. So it means there is no zero error, right? So nil, 0 error. Figure 2 shows the configuration corresponding to the measurement of the diameter d of a tube. The measured value of the diameter d is, right? So if you look at the first figure, from this figure we can relate the vernier scale division with the main scale division. So one main scale division, if you look at this diagram, one main scale division is 1 millimeter. So this length will be 1 millimeter. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 vernier scale divisions are coinciding with 1, 2, 3, 4, 5, 6, 7. 7 main scale divisions. So we can say 7 main scale division is equivalent to 10 vernier scale division. So one vernier scale division will be 0.7 times main scale division, and one main scale division is 1 millimeter. So that comes out to be 0.7 millimeter. Now from this data, we can find the least count of this vernier calipers, which is 1 main scale division minus 1 vernier scale division, which comes out to be 1 minus 0.7 or 0.3 millimeter. So we got the least count. Now let us find the reading. So we know that reading of a vernier caliper is given as main scale reading plus n times the least count minus 0 error. So main scale reading will be what? So this is the 0 of the vernier scale. So the reading to the left of the 0 of the vernier scale is the main scale reading, which will be 1 millimeter. So that will be 1 millimeter. And the first division is coinciding with the main scale. So n will be 1. And the least count is 0.3 millimeter. And 0 error is 0. So that comes out to be 1.3 millimeter, or we can say 0.13 centimeter. So that should be the diameter of the cylinder of the tube. So option C is the right answer. So this is question 5 of JEE Advanced 2025 paper 1. So let us first read the question. A conducting square loop of side L, mass M and resistance R is moving in the xy plane with its edges parallel to the x and y axis, and the region y greater than equals to 0 has a uniform magnetic field which is B naught k cap. The magnetic field is 0 everywhere else. At time t equals to 0, the loop starts to enter the magnetic field with the initial velocity v naught j cap meters per second as shown in the figure. Considering the quantity k is b naught square L square upon Rm in appropriate units, ignoring self-inductance of the loop and gravity, which of the following statements are correct? So let us see the options. So option A says if V0 is 1.5 kL, the loop will stop before it enters completely inside the region of magnetic field. B, when the complete loop is inside the region of the magnetic field, the net force acting on the loop is 0. So the force, okay, right. So we'll see that. If V0 is KL by 10, the loop comes to rest at this time. If V0 is 3 KL, the complete loop enters inside the region of magnetic field at time T, which is 1 by K ln 3 by 2. Again, it's a standard problem. So let us see. So for the option A, let us what we can do. Let us find the initial velocity which is required to have a stopping distance equals to L, right? So if stopping distance is equals to L, okay, right. So let us see what is actually happening. So as this loop enters the magnetic field, what will happen? The flux will change. Due to that change in flux, there will be a current induced in the loop, and that current will experience a force by the magnetic field. So if I show this in the top view, let us say this is x-axis and this is y-axis, and when this loop enters, say it has a velocity v. Now, and the magnetic field is in the z direction. So flux is increasing, right? So there will be a induced current in this direction, in the clockwise direction. Now this arm, the leading edge, will experience a magnetic force in the left direction by using IL cross B. So it will experience force in the left direction. Now due to this force, it will produce deceleration in the loop, right? So what we can write, the EMF induced will be BLV, where V is the instantaneous velocity, and the induced current will be BLV divided by the resistance, right? And the force will be ILB, which will be B square L square V divided by R. And I can multiply and divide this with M. So now this factor is nothing but K. So we are getting KMV, right? So that will be the force. Now if we apply Newton's second law, we can say KMV is nothing but negative of mass times the acceleration. Now let us find the initial velocity which is required to have a stopping distance equals to L. So I can write acceleration as minus, so acceleration can be written as v dv by dx, or it can be written as dv by dt, right? If you want to find the stopping distance, we can use the first relation. If you want to find the time, if velocity is given, we can use the second relation. So let us find the stopping distance. When the stopping distance is L, right? So let us find the velocity v naught. So kmv is equals to minus m, and this can be written as v dv by dx. So v will get cancelled out, m will get cancelled out. So from this we can say dx is equals to minus dv by k. So if I integrate this from 0 to L, velocity is varying from v0 to 0. So L is equals to minus v by k, and the limit will be from v0 to 0. So that will be v0 by k. So we can say v0 will be k times L. So it means if v0 is equals to kl, then the stopping distance will be L, and if v0 is less than kl, then stopping distance will be less than L. And if V naught is greater than KL, then it won't stop, right? It will enters the magnetic field, and after that the flux will become zero and it won't stop. It will keep on moving at the constant velocity, right? So let us see the first option. If V naught is 1.5 KL, the loop will stop before it enters completely. That is wrong. It won't, okay, right. So when V naught is greater than KL, it won't stop, right? It will enters the field and it will keeps on moving in the constant velocity. When the complete loop is inside the region of magnetic field, the net force acting on the loop is zero. So that is correct. There won't be any induced current, right? If V naught is KL by 10, so which is less than KL value, right? So it means it will come to rest. So loop comes to rest at t equals to 1 by k. So here, let us solve this part. So we have given so V naught is given as KL by 10. Now we're going to use, so from this we can say KMV is equals to minus MA. And for the second part, for the third part, we have to find the time. So we can write acceleration as dv by dt. So from this, m will get cancelled out. So k times dt is equals to minus dv by v. Now let us integrate this. So velocity is varying from kl by 10 to 0, and time will be from 0 to t. So this will be kt is equals to minus ln, that will be v, right? So from kl by 10 to 0. Or let me consider some velocity v, right? Let me take some velocity v. So this comes out to be minus kt is equals to ln v upon kl times 10. Now we can take, we can write this as v is equals to kl by 10 e raised to power minus kt, right? So you can clearly see that it is exponentially decreasing. So v will become 0 when t tends to infinity. So but in option C we have given some finite value, so that means it is incorrect. So C is incorrect. If V naught is 3kl, the complete loop enters inside the region of magnetic field at time t, which is 1 by k times ln 3 by 2. Okay, right. So let us find this, because if since V naught is greater than KL, so it will enter. So we have to find the time when it enters, right? So let us find the velocity when it enters the loop. So if I consider V as 3kl, so V is 3kl and kmv is equals to minus ma. So kmv is equals to minus ma. So first let us find the velocity by using the using v dv by dx formula. So kmv is equals to minus mv dv by dx. So this v will get cancelled out, mass will get cancelled out. So from this we get dx is equals to minus k dx is equals to minus dv. Let us integrate this. So velocity is varying from 3kl to v, and it will be from 0 to l, right? So kl will be equals to minus v from 3kl to v, so that comes out to be minus v plus 3kl. So v will be nothing but 2kl. So we got the speed or velocity of the loop when it just enters completely inside the magnetic field. Now we again use the same relation. So kmv is equals to minus m dv by dt, right? So from this m will get cancelled out. So k dt is equals to minus dv by v. Let us integrate this. So it will be k t is equals to minus ln V, and the limit is from 3KL to 2KL. So that comes out to be minus ln 2 by 3. So we can say the time taken by the loop to enter completely in the magnetic field will be 1 by K times ln 3 by 2. Let us check the option. Yes, so option D is the right answer. So for this question, B and D is the right answer. This is question 6 of JEE Advanced 2025 paper 1. So let us read the question first. Length, breadth and thickness of a strip having a uniform cross section are measured to be 10.5 centimeter, 0.05 millimeter and 6 micrometer respectively. Which of the following options give the volume of the strip in centimeter cube with correct significant figures? Right, so if you look at the significant figure in length, it will be 3, right? And in breadth, it will be 1. And in thickness, it will be 2. And we know that if we are taking the product of the quantities, right? In that case, the final result should be rounded off to this least number of significant figures. So we can say significant figures in result should be minimum of length, breadth and height or thickness, right? So the answer should have one significant figure because breadth has a significant figure 1. So if you look at the option, it has 2 significant figures, it has 3, it has 2, it has 1. So option D should be the answer, right? So without any actual calculation, you can mark option D as the correct answer. Now this is the question 7 of JEE Advanced 2025 paper 1. So consider a system of 3 connected strings S1, S2 and S3 with uniform linear mass density mu, 4 mu and 16 mu in SI units respectively as shown in the figure. S1 and S2 are connected at point P, whereas S2 and S3 are connected at the point Q, and the other end S3 is connected to a wall. A wave generator O is connected to the free end of S1. The wave from the generator is represented by this equation, y0 cos omega t minus kx in centimeters, where y0, omega and k are the constant of appropriate dimensions. Which of the following statements are correct? Right, so here if you look at the options, right, so let us see the first option. When the wave reflects from P, for the first time the reflected wave is represented by this equation, where alpha 1 is a positive constant. Right, so here we have to take an assumption. If we are considering the junction P, will assume that our origin is at this particular point, right? So let us say if you're considering, so this assumption we have to keep in our mind, otherwise we won't get any of the options as correct. So if we consider P as the origin, right, so in that case, if there is a pulse which is coming and this PQ string is heavy, right, so we know that when a wave is going from a rarer to a denser medium, then the reflected ray will be out of phase, so the reflected pulse will look like this, right? So we can say for A part, the reflected pulse will be, so since they have taken alpha 1 times y0, obviously the amplitude of the reflected pulse will change because energy is getting distributed in the transmitted as well as the reflected wave. So this can be written as alpha 1 times y0 cos. So here the reflected pulse is in the same medium as S1, right? So we can say it will be omega t, and its direction has reversed, so there has to be a plus kx, k will be same, right, because we are in the same medium, plus pi, right? So if we consider origin at P, then option A is the correct answer. Let us see B. When the wave transmits through P for the first time, the transmitted wave is represented by this. So if you look at this here, they have taken angular wave number same as the angular wave number in S1, but we know that the speed changes, frequency will remain same, and we know that speed is given as root of t by mu, and we can write speed as omega by k. So we can say k is directly proportional to square root of mu. So if we have angular wave number k in S1, then it will be 2k in S2 and it will be 4k in S3. So that we have to keep in our mind. So here they have taken k only, so that means B is incorrect. So when the wave reflects from Q, again they have taken K, which is incorrect, right? It should be 2K. Now let us see the last option. When the wave transmits from Q for the first time, the transmitted wave is represented by. So again, for the fourth option, I'm using the assumption that they have shifted the origin at Q, right? So if this is x equals to 0, then let us check for D part. Transmitted pulse. So yt will be alpha 4 times y naught, which they have taken, and it will be cos omega t, and it is going in the positive x direction, so minus k will become 4k, and there won't be any change in the phase because transmitted pulse will be having same phase as the incident pulse. So option D is the correct answer, right? So again, here you can challenge this problem because they have not specified that we have to shift the origin, right? So I have considered this assumption. So according to that assumption, A and D is the right answer. So this is the question 8 of JEE Advanced 2025 paper 1. A person sitting inside an elevator performs a weighing experiment with an object of mass 50 kilograms. Suppose that the variation of the height y of the elevator from the ground with time t is given by 8 times 1 plus sine 2 pi t by capital T, where capital T is 4 pi seconds. Taking acceleration due to gravity as 10 meters per second square, the maximum variation of the object's weight as observed in the experiment. Right, so let us try to find the variation. So here we know that the maximum weight will be m times g plus a, and the minimum weight will be m times g minus a. Okay, so let us find the acceleration of the lift. So we have to double differentiate y with respect to time. So dy by dt will be 8 times 2 pi by capital T, which is 40 pi, times cos 2 pi t by capital T. So this will give us 20, and this will be 2, and this will be 5. So we got 2 by 5. So let us differentiate again. So this will be 2 by 5 times minus of 2 pi by 40 pi times sine 2 pi t by capital T. So 20, and this will be 10. So I'm getting 1 by 50 with a negative sign, sine 2 pi t by capital T. So we can say A max will be 1 by 50 and A min will be 1 by minus 1 by 50, right? So we can say maximum weight will be 50 times g, we have to take 10, plus 1 by 50, and minimum weight will be 50 times 10 minus 1 by 50. Now from this, maximum weight will be 500 plus 1, and minimum weight will be 500 minus 1. Now they are talking about the maximum variation. Usually when we talk about variation, it is the variation from the mean value, right? So here we can say the weight is 500 Newton. So how much it has changed? So ideally it should be 1, right? Suppose if I plot the weight, right? Let us say it is varying like this, right? So this value, this is 500 Newton, and this is 501, and this value is 499. So the variation from the mean value is 1, right? 1 Newton. So if the examiner wants you to find the variation or the difference in the maximum and the minimum weight, then the answer will be 2 Newton. Or actually, like by this statement, the statement is ambiguous. If they're talking about maximum variation, it should be how much it is varying from the mean value, right? So the correct answer should be 1 Newton, or they should also give 1 Newton or 2 Newton, right? Okay, right. So this is the question 9 of JEE Advanced 2025 paper 1. A cube of unit volume contains 35 into 10 raised per 7 photons of frequency 10 raised per 15 hertz. If the energy of all the photons is viewed as an average energy being contained in the electromagnetic wave within the same volume, then the amplitude of the magnetic field is alpha times 10 raised per minus 9 Tesla. Taking permeability of the free space mu naught as 4 pi into 10 raised to minus 7 in SI units, Planck constant as 6 into 10 raised to minus 34 in SI units, and pi is 22 by 7, the value of alpha is. Right, so again it's a direct formula based question, and we know that the energy density, so energy density is given as of EM wave is 1 by 2 mu naught B naught square. Now if you multiply this energy density with the volume, which is given as 1 unit, will give us the energy, right? So total energy. So total energy in unit volume will be 1 by 2. Mu naught is 4 pi into 10 raised to power minus 7. And B naught we have to calculate, right? So B naught square, and that should be equals to how many photons we have? 35 into 10 raised to power 7 photons. So it will be 35 into 10 raised to power 7 times the energy of one photon, which will be h nu, 6 into 10 raised to power minus 34, and frequency is given as 10 raised to power 15. Now from this, so B naught square will be, so we have 4 pi. Let us take it on the other side. So 35 times 6 times 8 times 22 by 7 times 10 raised to power 7 minus 34 plus 15. So this will give us 5. So we are getting 16 into 11 into 30, the root of that, times 10 raised to power, so it will be 15, 19, minus 19, root of that. So let me take this, so this can be written as plus 1. So it will be 4 root 33 times 10 raised to power minus 9. So alpha will be 4 times root 33. So if we simplify this times 4, so we are getting 22.98. So the it should be 22.98. So you will get some range, maybe 22.96 to 23.00, something like this they will give you for this question. So this is the answer. This is the question 10 of JEE Advanced 2025 paper 1. So two identical plates P and Q radiating as black bodies, so E will be 1, are kept in vacuum at constant absolute temperature Tp and Tq respectively, where Tp is greater than Tq. Shown in the figure, the radiated power transferred per unit area from P to Q is W naught. Subsequently, the two Moore's plates identical to P and Q are introduced between P and Q as shown in the figure 2. Assuming the heat transfer takes place only between the adjacent plates, if the power transferred per unit area in the direction from P to Q in figure 2 is in steady state is Ws, then the ratio W naught by Ws will be. Again, it's a standard problem, right? So what we can say, so W naught is power per unit area, transferred power per unit area. So that will be sigma times, so temperature of P is more, right? So that will be Tp raised to power 4 minus Tq raised to power 4, right? So that is W naught. And let us say the temperature of these two plates, it has a temperature T1, it has a temperature T2. And in steady state, the power transferred per unit area from Tp1 to T1 will be same as the power transferred from T1 to T2, same for the power transferred from T2 to Tq. So we can write WS. So WS will be sigma times TP raised to power 4 minus T1 raised to power 4. And this is also equals to sigma times T1 raised to power 4 minus T2 raised to power 4. And it also equals to sigma times T2 raised to power 4 minus TQ raised to power 4. Okay, so now basically we have to eliminate. Now we have to eliminate T1 and T2 from these equations. So let us add them. So if we add, we'll get 3WS is equals to sigma times TP raised to power 4 minus TQ raised to power 4. And this right hand side is nothing but W naught. So W naught by WS comes out to be 3. Right? So 3 should be the answer of this question. So this is question 11 of JEE Advanced 2025 paper 1. So let us read the question first. A solid glass sphere of refractive index root 3 and radius capital R contains a spherical air cavity of radius r by 2 as shown in the figure. A very thin glass layer is present at the point O. So at O we have a very thin glass layer so that the air cavity of refractive index 1 remains inside the glass sphere. An unpolarized, unidirectional and monochromatic light source S emits a light ray from a point inside the glass sphere towards the periphery of the glass sphere. If the light is reflected from the point O and is fully polarized, so it means whatever light which is being released by the source, that light ultimately end up at O, and at O, after reflection we are getting fully polarized. So it means it is hitting this interface at O at Brewster angle, and we know that if it is hitting at the Brewster angle, then Brewster angle is given as tan B is equals to, in this case, mu of a denser, mu of a rarer, right? So denser medium will be root 3 and rarer will be air. So Brewster angle will be 60 degrees. So it means the light is getting reflected at O will have an angle of incidence of 60 degrees. Then the angle of incidence at the inner surface of the glass sphere is theta, the value of sine theta. Okay, right. So let us plot the ray diagram here. So here after reflection, so this is the reflected ray. Okay, let me show the normal with green color. So that is the normal at this particular point. This is the normal at this point. So angle of incidence will be equal to angle of reflection. So this is theta, this angle is also theta, right? And after that it undergoes something like, so this is the ray, reflected ray, and this is the normal, and then this ray will move, so it will bend away from the normal, right? Okay, let me redraw this. So this angle is also theta, and this is the normal, and then it will bend away from the normal and hitting O, right? And this angle will be Brewster angle, right? So this angle will be 60 degrees, right? So this is 60. We know this angle should also be 60, right? And if we apply Snell's law at this particular point, we can say 1 times sine 60 will be equals to root 3 times sine r. So this will be root 3 by 2 times 1 by root 3 is equals to sine r. So we can say r is nothing but 30 degrees, right? So this angle will be 30. Okay, right. So now we can find theta by using geometry. So let me join these 2 points and these 2 points. So this angle is 60, and this angle in a semicircle is 90. So this angle will be 30 degrees. So this angle is also 30. So we can say this angle will be 120 degrees. Right, let us pay emphasis on this triangle, right? So I'm considering this triangle. So I'm going to use Lami's theorem here. So sine theta divided by the side opposite to theta will be this side, right? And this side is nothing but 2r by 2 cos 30. So basically I have taken projection of this radius and this radius in this direction, and that should be equals to sine 120 degrees divided by the side opposite to 120 degrees, which is nothing but the radius capital R. So this will get cancelled, R will get cancelled. So sine theta comes out to be, cos 30 will be root 3 by 2. Sine 120 is also root 3 by 2. So that comes out to be 3 by 4. So in decimals, up to 2 decimal places, it will be 0.75. So 0.75 is the answer. So let me write here 0.75. So this is question 12 of JEE Advanced 2025 paper 1. A single slit diffraction experiment is performed to determine the slit width using the equation BD by D is equals to m lambda, where B is the slit width, D is the shortest distance between the slit and the screen, and small d is the distance between the mth diffraction maximum and the central maximum, and lambda is the wavelength. And capital D and small d are measured with the scales of least count 1 centimeter and 1 millimeter. So we can say delta D is 1 centimeter and delta small d is 1 millimeter. And the value of lambda and m are known precisely to be 600 nanometers. So lambda is given as 600 nanometer and m value is given as 3. The absolute error in micrometer in the value of B estimated using the diffraction maximum that occurs for m equals to 3, d is equals to 5 millimeter, and capital D equals to 1 meter. So if you look at the error in small d, so the error is 1 millimeter, whereas the d value is 5 millimeter. So this error is quite large. So we can say delta D is not very small in comparison to d, but still if we try to find the answer by using calculus approach, so we can say we have the formula B D by capital D is equals to m lambda, and we have to find the absolute error in B. So B can be written as m lambda capital D by small d, where m and lambda they have no error. So we can say delta B by B is equals to delta D by D plus delta small d by d, right? So if I use this relation, so we can say delta B will be delta D by D plus delta small d by small d multiplied with B, and B is d lambda m by small d, right? So let us substitute the values. So delta D is given as 1 centimeter, where D is 1 meter, so 100 centimeter, plus small d, delta error in small d is 1 millimeter, and d small d value is 5 millimeter, right? So capital D is 1 meter, lambda is 600 nanometers, so 6 into 10 raised to power minus 7, and small m is 3 divided by small d, which is 5 into 10 raised to power minus 3. So it will be 0.01 plus 0.2 times 18 by 5 into 10 raised to power minus 4, or we can write this as 0.21 times 18 by 5 into 10 raised to power minus 4, and we have to find in micrometer. So this will be 21 into 18 by 4 micrometer, right? So if we simplify this, so 21 times 18 divided by 5, it gives you 75.6. So by using calculus approach, we are getting 75.6 micrometer. So this is question 13 of JEE Advanced 2025 paper 1. So consider an electron in n equals to 3 orbit of hydrogen-like atom with atomic number Z. At absolute temperature T, a neutron having thermal energy kBT has the same de Broglie's wavelength as that of this electron. If this temperature is given by this expression, where h is a Planck's constant, kb is the Boltzmann constant, mn is the mass of the neutron, a0 is the first Bohr's radius of hydrogen atom, then the value of alpha is. Right, so first let us calculate the de Broglie's wavelength of neutron, and to find that we need to find the momentum of the neutron. So kinetic energy is given for the neutron, that will be kBT. And we know the kinetic energy is p square by 2m, where mn is the mass of the neutron. Now from this we can find the de Broglie's wavelength of neutron, that will be h divided by root of 2mn kBT, right? So we got the de Broglie's wavelength. Now let us find the de Broglie's wavelength for electron, right? So for that we require the expression for Bohr's radius. So let me do that. So there is an electron which is revolving in a circular orbit. The radius is r and the speed is v. So we can say the centripetal force will be nothing but the Coulomb attraction between the nucleus and the electron. So it will be ZE square divided by 4 pi epsilon naught times r square will be mv square by r. So this will get cancelled out. So ZE square will by 4 pi epsilon naught will be mvr times r, sorry, mvr times v, and mvr is nothing but nh upon 2 pi, which is 3h upon 2 pi. So this can be written as 3h upon 2 pi times v ZE square divided by 4 pi epsilon naught. Now this will give us 2. So we got v, which will be ZE square divided by 6h epsilon naught. Right, so we know that m ZE square upon 6h epsilon naught times r will give us 3h upon 2 pi, like angular momentum. So from this we can find r, which will be 18h square epsilon naught by 2 pi m ZE square, right? And this can be written as, so this will be 9. So it comes out to be 9 h square epsilon naught divided by pi m e square, and then we have 1 by z. Now this vector is nothing but the first Bohr radius. So it will be 9 a naught by z, so that is r. Okay, so let us find the, so h square. So let us find the de Broglie's wavelength of electron. So that will be h divided by mv, and v is ZE square times 6h epsilon naught. So it will be 6h square divided by m e square, and then we have z, and there is an epsilon naught, right? And we know that epsilon naught times h square upon m e square. So let us multiply and divide with pi. So this vector is nothing but Bohr's radius. So that will be 6 a naught pi by z. So we got lambda. Now what we're going to do, we'll equate the neutron wavelength with the electron wavelength. So when we do that, let us square and equate them. So h square divided by 2mn kBT is equals to 36 a naught square pi square by z square. Right, so if we rearrange the terms, this will give us alpha as 72. Right, so 72 is the answer of this question. So this is the question 14 of JEE Advanced 2025 paper 1. So list 1 shows the 4 configuration, each consisting of a pair of ideal electric dipoles. So ideal means they are very short dipoles. Each dipole has a dipole moment of magnitude p, oriented as marked by the row in the figure. In all the configuration, the dipoles are fixed such that they are at a distance 2r apart along the x direction. The midpoint of the line joining the two dipole is x. The possible resultant electric field E at x are given in the list 2. Right, so let us match. So let us see the first list. Let us see the P part. So here we have two dipoles arranged in this order. So due to the first dipole, the field will be in the downward direction. Due to the second, it is also in the downward direction. And we know that X is at a equatorial position with respect to both the dipoles, and the field will be Kp by r cube. So it will be 2 Kp by r cube with a negative j cap, right? Which is nothing but 2, right? So we can say P corresponds to 2. So we can eliminate option A and B. Now let us check for R, right? So in case of R, we have due to the left dipole, the field will be in the downward direction, and due to this one, the field will be in the right direction. So we can say in this case, it will be 2 Kp by r cube I cap minus Kp by r cube j cap. Okay, so we can say Kp by r cube will be common, so it will be 2 I cap minus j cap, right? So Kp by r cube 2 I cap minus, so fourth, right? So option C is the right answer. Now this is question 15 of JEE Advanced 2025 paper 1. A circuit with an electrical load having a impedance Z is connected with an AC source as shown in the figure in the diagram. The source voltage varies with time as 300 sine 400t. So omega is given as 400 and the amplitude of the voltage is given as 300. Where t is in seconds. List 1 shows various options for the load, the possible current I in the circuit as a function of time. So again, very basic question. So in the first case, the load is purely resistive. So it means the current will be in phase with the applied voltage. So if you look at the options, in this case, the peak value of the current will be 300 divided by 30, that will be 10. And it will be a sine function only, right? So let us see the option. So it comes out to be the third one, right? So P corresponds to 3. So we can eliminate B and D. Now let us see the Q part. It's a, so basically it will be inductive load, right? We have an inductor and there is a resistor. So first let us calculate the impedance in Q part. So impedance, first let us calculate the XL value. Omega is given as 400. Multiply that with L, which will be 0.1 Henry, which will be 40. So impedance will be root of 40 square plus 30 square, that will be 50. So we got the impedance. So peak current in this case will be peak voltage divided by the impedance, which is 50. So it comes out to be 6. And we know that in inductive case, the current lags. So if I write down current, so I will be 6 sine 400t minus, let us find the phase difference. So tan phi will be XL by R, and XL is 50. XL is 40 divided by R is 30. So phi comes out to be 53 degrees. So it will be minus 53 degree. So it means at t equals to 0, I will be 6 times minus sine 53 is 4 by 5. So that will be minus 24 by 5, which will be minus 4.8. Right? It will be minus 4.8. So let us see the option. At t equals to 0, the value should be minus 4.8. So can you see in the fifth option, it is slightly above minus 5, right? So C, so 5 is correct. So for Q, it should be 5. So option A is the right answer. So this is question 16 of JEE Advanced 2025 paper 1. List 1 shows various functional dependency of the energy E on an atomic number Z. Energy associated with a certain phenomena are given in the list 2. So let us see in list 1. Okay, right. So we can clearly see that the Q is energy is proportional to Z minus 1 square, where 1 is the screening constant, right? So it is the Moseley's law, right? So means the characteristic X-ray. So Q corresponds to 1, right? So we can eliminate other options. So option C is the right answer.